All right, I would like to welcome all of you to today's NUG community call. Today's call is going to be an interesting panel discussion on an honest conversation on HPC programming languages. And my name is Charles Lively. I'm a science engagement engineer here at NERSC, along with my counterpart, Dr. Lippy Gupta. Lippy, did you want to give everyone a little hi?
Hi, thanks all for being here today.
Um, So we will get started with today's panel discussion. Um, it's going to be a very interactive panel, and we have five nurse staff members here that are going to give their thoughts and their perspective on how they view and utilize different programming languages to help them achieve their goals and their work. And so what we'll just go ahead and do is jump right in with our introductions of our panelists. And so first up, we have Brandon Cook.
All right. Yeah, I guess I'm up first. Hi everyone.
Uh,
I'm Brian Cook. I lead the programming environments and models group here at NERSC. I wear lots of hats. Among those, I'm also the principal rep for Insights, which is the US version of ISO standards for different programming languages for Berkeley Lab. Um, I've used pretty much every HPC language out there in one form or another. Um, I think my sort of perspective here isn't so much as a consumer of the languages. My focus and a lot of the focus of our team is really thinking about the users, so the users of how can you program HPC systems and get the most out of it for your scientific results. And then how does that translate to the architectures that we have at NERSC, both the current one and whatever's next. Yep. Thanks, Charles.
Awesome, awesome. And Brandon being our lead for our programming environments group, he's a perfect person to speak on this topic. And I do know my ABCs, but I guess Brandon got copied a little bit before Johannes. Johannes, in alphabetical order, should have been first, but Johannes, go ahead and take the floor.
B comes before J. So yeah, I actually prefer Brandon to go first. I feel like I have a lot of the same things to say as Brandon. So I would say if you don't remember anything else about my background, it's basically I'm I'm like Brandon, but I like Julia more. Uh, so so yeah, I also wear many hats. Maybe the two hats I want to highlight in this group are together with Neil Mehta. We lead the NESAP program. So if you haven't heard about NESAP before, you chat with me later or look it up on our website. It's an excellent program to get you and your team started on on the future HPC systems. And then also at NERSC, I'm the NERSC contact for the LCLS real-time data processing pipeline, and in general, I focus a lot and do a lot of research on in interconnecting HPC resources with experiments like telescopes and particle accelerators and that sort of thing. I want to point out that I haven't encountered a language yet that I didn't like, even though I do like Julia the most. I really enjoy the fact that every new language I learn gives you a new tool that allows you to think and approach problems slightly differently. So in that context, I also spend a lot of time at NERSC thinking about how programming languages in HPC can serve especially new researchers to HPC in such a way that their science gets done faster.
Awesome. Awesome. Thank you so much, Johannes. And so next we will be moving right along to Nestor. Nestor?
Hello everyone, I'm Nestor Demer. I'm part of Brandon Cook's team, so I'm also in the programming environment and models team. And I have touched a bunch of languages. I've done the lower level ones, so a lot of C, C++. I have done the new fancy ones, so I've done some Julia, some Rust, Python with JAX, things like that. And also a lot of functional ones, so OCaml, F#, those weirder cousins that have interesting ideas. And at NERSC, I'm the referent for Rust, so lower level language with really good support for parallelism, thought, add language design, and very modern tooling. So hopefully giving you C++-like performance without C++ pain. And JAX, which is not technically a language, that's a Python library, but it comes with its own compiler, its own semantics, so it blurs the line between language and libraries. And the main thing I tend to think about is the accessibility of HPC, is how do I get researchers to have their ID and write their code by themselves and have it run efficiently on a supercomputer without me having to do any work? That's the end goal for me.
Okay, awesome. Awesome. Thank you for your overview. Next up, we have Amanda.
Okay, so hello everyone. Thanks. I would like to thank Charles for inviting me to this panel. So my name is Amanda. I work at NERSC at Lawrence Berkeley National Lab in the Application Performance Group. I completed my bachelor's and master's degrees in meteorology and my doctorate in scientific computing. So here I listed some HPC projects that I have been working with in the last few years. So they are different projects, but basically what I do is to develop and optimize codes, conduct experiments to validate these codes and evaluate their performance. So the idea is to make these codes more efficient and viable for operational or scientific applications. So the first two projects that I listed here are examples of projects that we started from scratch, so we could choose the language that we would like to work with. So in the first project, the code is written in C, C++, POCO, C++ libraries, OpenNP, and OpenCL. And in the second project, the code is written in C, C++, and OpenCL. So the third HPC project listed here is an example of a project where even without knowing anything about the application, I was able to implement the SQL version of milk_benchmark and optimize this code. So this code is written in C++, and SQL. So if you ask me why I choose OpenNP, OpenCL, and SQL in this project, I would say that these three languages are examples of open source, portable, and single source programming models. So it means that these codes we can run in many devices, GPUs, CPUs, FPGAs, and many others from different vendors, for example, NVIDIA, AMD, Intel. So the idea is that we don't have to rewrite these codes every time that the system changes. But sometimes we can choose the language that we would like to work with, especially when we are joining a project that has been around for many years. So that's the case with the last HPC project, where the code is written in C, C++, C++ threads, CUDA, and MPI. So given the choice, I would avoid proprietary language like CUDA because we can run CUDA codes only on NVIDIA GPUs. So my preference is always to work with open source, portable, and single source programming models. So that's it.
Okay, awesome. Thank you so much for that wonderful overview, Amanda. Looks like you work with a lot of different parallel languages for HPC. So it's going to be interesting to poke your brain on some of the differences. All right, and moving on next. Oh, 1 second. Looks like maybe Rahul, your slide did not get copied. So give me 1 second to pull that up. Sorry about that.
That's fine.
Monty is hearing a little noise outside. And now we will continue with Rahul. He got away from me.
Okay, I guess I can just start talking and then you could, okay. So hi everyone, good morning, and thanks Charles for inviting me on this panel. Right, so I am more or less like the previous panelists that you heard. I have dabbled in most of the programming languages that are available on GPUs, but only on the C++ side. I have no experience on the Fortran side. At NERSC, I'm mainly associated with Cocos. I'm one of the primary developers of the Cocos framework, if you know the Cocos framework, and OpenMP for GPUs especially. I started my journey at NERSC as a postdoc, as a user of these programming models. Then I moved on as a staff member to be one of the developers of these programming models. And then now, for the last couple of years, I have been more or less thinking about how to make these programming models accessible to our users in an efficient and easy way, which is also the goal of the group that I am a part of, which is the Programming Environments and Models group that you heard earlier. I do not have a single programming model that I want to evangelize because different people's needs are satisfied by different models. But I do believe that between Cocos and OpenMP, almost every C or C++ code should be able to parallelize in a portable manner.
Awesome. Awesome. So thank you everyone for all of our panelists for providing their introductions and overview of some of the different languages that you all work with. What we want to do now is get started with an interactive discussion. We welcome all of our attendees to provide or answer or ask questions that you might have pertinent with regards to your thoughts on different programming languages from our panelists. But what we can also do is get started with, I have a seed question for everyone. And that specific question is, how do you feel that the specific architecture of the system influences your choice on the programming language or the library that you use? What helps you to govern or decide that with regards to the different systems? And if we want to, anyone that wants to go ahead and start.
I can go ahead.
If you want.
Okay.
So the big thing is nowadays we have a GPU system. And so we need language with good GPU support. We need language with good GPU libraries. And for example, I really love Rust. I'm really trying to pass Rust on people. But right now, you're not going to write GPU code in Rust natively. You're going to write CUDA and call that. So nowadays, if you want to make the best use out of the system we have available, and most systems are doing that same movement from, oh, you need to think about multi-core to, oh, you really need to be able to use those GPUs. You need to have that built into the language.
Good. Amanda, you wanted to contribute something as well?
Yeah, no, I was just thinking that I think my perspective is try to think always in a general way, because if you are focused on a specific architecture or a specific system or supercomputer, we it's gonna be a really challenge in the future because we don't know about the future. Nowadays, GPUs is the most popular architecture, but we don't know about the future. Maybe in the future, we're gonna have another architecture that is gonna be better than GPUs. So I think the idea when we are thinking about a project and develop a code that we wanna that maintain for the future, we have to think about architectures in general, like because we don't know about the future. And so this is why I always prefer to work with open source and portable and single source programming languages to maintain this language and to have this language for many, 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 many years, no matter what architecture we have in the future.
Yeah, I will build on what Amanda said. So I agree entirely everything what Amanda said, and I want to add to that the community and around that language is really important. Really, languages are a way of communicating with a greater community without having to talk to everyone directly, right? And so if you see that, and then this is really the way that I choose not so much languages but packages and tools more broadly is how generally open the community is to new ideas, and then also how HPC aware the community is. So to concretize that with 2 examples, neither of these communities will be named because I don't really want to like throw shade here. At one point, I was talking in one group, and they were like, "Well, HPC, you know, y'all are just a dinosaur. It's the cloud, so go away. I don't want to engage with that." And another one where it was very easy then to incorporate some of the quirks of the HPC system into that package. And so, of course, you're going to be much more productive if your community represents the latter rather than the former.
Okay, good. Brandon, you had wanted to contribute your thoughts next.
Yeah, I guess I'll take a slightly different kind of approach to answering. I think first and foremost, I work for NERSC, so the architectures here at NERSC, our focus is to make sure that those actually meet the needs of the user community. So a lot of that is really kind of a different type of back and forth. We take that into an account when we select our architecture's choices for the next machines. And then once we know what architectures we have, so for example, like people mentioned, Perlmutter has GPUs, then we also continue to work to make sure that those languages that we see people using and asking for work well with those. I think in terms of like backing up a little bit more broadly, in terms of architecture, one thing we do need to think about are the broader trends in the computing industry, right? So if all the billions of dollars in the world are going into AI and AI-focused models, it's important to think about how we can leverage this investment for scientific use cases for you. And then I guess maybe it's getting ahead, but I think there's also portability is a nice ideal, and it's important for all of us who likely have, research accounts at, let's say, Oak Ridge or Argonne or some other kind of HPC center to think about what are our target systems that we want to support with our codes. And I guess I'll just say, I don't think there's really such a thing as performance portability. What you're really doing is finding a good abstraction layer that lets you make it somebody else's job to do the performance portability for you. So like Cocos is great, you can write Cocos, but if you go ask a Cocos developer, they have to know about CUDA and SYCL and HIP and whatever else. And so I think that that's kind of one dimension. And then the other piece of architecture is lots of these cool systems have fancy new things that the hardware can do. And I think it's nice to think about how can the programming model of whatever language kind of expose what that hardware can do into your science application without you having to know as a user how to program a network card or write PTX assembly code for a tensor core. So that's my take on architecture and language.
Awesome. Very insightful, Brandon. Rahul, you had wanted to contribute your thoughts?
Yeah. Okay. I kind of lost my thought when I was listening to Brandon. Yeah. Sorry. Firstly, I want to say that I agree with everybody that has said things before me, all four of them, because everybody's adding a new dimension to the same point. It's not that somebody's contradicting the other. I just wanted to add another dimension is like when you're actually choosing what model or language you want to use, you also want to think about like what is your use case? Like, are you in most of the cases, for example, C++ language is actually moving in a way where if you want the basic parallelism for HPC system or for any system, the language itself is providing you with features that you can use, and you only go to like a vendor specific or something other than the language if you need that additional 15-20% of the performance. But if you say, okay, I don't care about 15-20 performance, 15-20% additional performance, I care about my science and faster science, so I can write my code faster and get my science results faster, then don't do complicated things. Do things that will just reach you towards that goal. Like, what is your goal and what you are comfortable with? If you're comfortable with Python, almost every vendor, NVIDIA is leading in that, but they are trying to get libraries for every domain of science that people are working on, including AI and ML. So use their expertise and you focus on your science. That's my like thought at least.
Um, Very interesting perspective, Rahul. Nestor, you wanted to add your thoughts?
Yeah, what both Raul and Amanda touched on the side. There is something that's I see growing more and more, which is the idea of separation of responsibilities, of writing your code, focusing on the semantics. So in Cocos, you're like, I'm just writing a loop. I don't know how it's going to run, where it's going to run. It's Cocos' job to do that. In Jax, same thing. It's like, oh, I'm focusing on the math. That array goes here, does that. I have no idea whether it's going to run on a GPU, on a TPU, whether it's going to be distributed or run sequentially, because maybe here that's the best way to go. So having libraries and language that let you focus on your domain-specific thing, which very often is what Brendan said, finding the right abstraction for you and for the kind of stuff you're doing. You work within those abstractions. And then an independent layer is focusing on optimization for your target hardware. And that gives you portability in the long term, because when you want to move to a different system that use TPUs or something else, the thing that evolves is not the math, it's not the science, it's the optimization bit. And vice versa, when the math and the science evolve, you don't think about optimization, you think about just implementing the math and the science in your domain-specific language. And that has been growing more and more.
Awesome. Johannes, did you have some additional thoughts to contribute?
Yeah, I wanted to maybe throw a wrench in the works here a little bit by yes, and I think especially in HPC, it's useful to keep in mind that I think we're using sometimes overbroad categories in terms of like what a user is, right? I like to think of it in terms of a spectrum. You might have on one end of the spectrum folks that think in terms of DSLs, so domain-specific languages, for example. They want to really just express a particular problem to the supercomputer and get an answer out. And then on the other end, and often, and this is where I think I'm throwing a wrench in the works, often I think AI is framed that way, right? Surely you just want to have a labeled data set and do root mean square minimization on this thing, right? And then there's the other end of the spectrum where folks actually need to dive really deep into the guts of their packages and their languages. They're doing almost like computing research. They don't necessarily call themselves computing researchers. I know a lot of folks that do computational fluid dynamics that would also qualify as computing researchers. And there, it's not helpful to think in terms, in my opinion at least, it's not helpful to think in terms of DSLs. There, the idea of like static package ecosystems and please just stay in your box gets in the way quite a lot, right? Like, what if my PyTorch loss function becomes this weird thing that can't be expressed as like a Python operator, right? At that point, you're getting, things get nasty. And so often I think a lot of friction, because you were asking about choices of languages and packages, Charles. In my engaging with all kinds of different users, I think a lot of frustration comes around when someone makes one choice, like, oh, I'm going to use Python because the whole world uses that for AI, but hasn't really realized that they are not the typical AI user in this example. And now they're using almost the wrong tools for that problem. They maybe were better served with Jax or Julia or something like that. Anyway, so I want to also therefore advise folks here, since this I guess is also advice, really understand what kind of user you are, and you know, don't be too conservative, especially if you're already doing much more researchy work rather than just users of packages. Anyway, I yield my time.
Okay, good. Interesting points. Rahul, did you want to add something in as well?
Just one point, but I also think that it's, yeah, at some point we might need to give breaks so that users can also start asking questions. I just wanted to say, because there was a lot of portability word thrown around, I just wanted to say that almost every language and programming model is striving for portability. How successful they are, that's a different issue. Including CUDA, there is a Clang CUDA work that's going on to make CUDA portable on other framework, on other GPUs. But that's all. Yeah. So if portability is your concern, then almost every framework has some implementation for every other architecture. How good that implementation is, that's a different issue. They always target one or two primary architectures.
Yeah, that's always dependent on the system. Nestor, did you wanted to add something else?
Tiny thing about what something Johannes said. He said, don't be too conservative with your choices. And that's very much something I see where you see interns and undergrads trying those newfangled languages and writing code that ends up doing really interesting stuff. And you see other group of people who are like, I do not want to learn a language. I knew Fortran. Fortran is still running on the machine. There is no reason for me to touch anything else because the math are going to be able to be written in Fortran. That's it. And often, yes, that's true, but also we could write assembly language if we wanted. That's going to run, but we might be better served spending time focusing on the science, maybe. So I think there is really an argument to be made for those new languages are easy to pick up and often very, very productive and delivers on performance, delivers on facilities that you might not have. For example, if you care about being able to do differentiation, you can do that in Fortran. You can even do stuff inside the Fortran compiler to get automatic differentiation, but that's going to be a lot of pain. In Julia, you just get a library that comes with differentiation out of the box and your life is going to be nice. So try languages. Give them a try, even if you don't keep them. There is a lot to be gained there.
Good point. Brandon, did you want to add some additional insights?
Yeah, I guess I'll do. Well, I guess as the representative for Fortran and the crowd, I guess I am compelled to just point out that it's also new features in old languages. So these things don't stand still. There's lots of cool stuff in modern Fortran that in some ways it has a nicer object-oriented model if that's your thing than C++, for example. Some people might be surprised to learn. It's also, if people like PGAS programming, it's one of the few and oldest out there for that. But I guess I also wanted to, and tell me if I'm going off script, Charles, but I wanted to kind of turn towards Alan's question in the chat and
Awesome. I was going to segue to that
and
afterwards, so you can
and
go ahead
maybe
and take it away.
and so I think that that's related. I mean, I'll say if you have a researcher, if you're a researcher that's using a laptop to great effect and that's meeting your scientific needs, then you know, I don't see that as a problem, right? Keep doing the thing that supports what needs to happen for, you know, your research outcomes.
Could I chime in on that and give
Yeah, sure. And
I mean,
I was,
of course, I would agree with you, but
yeah.
I suspect that there is a psychological hurdle in terms of, well, it's good enough on my laptop. I don't know how to use these other machines and I don't want to learn. So you sort of psychologically declare that you're happy on the, but if it was really easy to move to HPC, I think that something different would happen.
Oh yeah, and I think I'll just well, I don't want to make Nestor's point for him, but I'll say I think with many of these modern approaches, a really key element of the design consideration of like evolving these languages is what's that on-ramp, right? And there's not necessarily you know, a specific answer of, you know, let's say you have some totally serial code that works great, and maybe you go through and sprinkle some language native do concurrent or, you know, C++ parallel for each whatever, or some OpenMP directives, and then you're a little bit happy. But then you want to go even faster with like a few key routines. Well, maybe you go and write that piece in like Cocos or CUDA or even assembly if it's important enough, right? As you kind of look to scale up. So I think it's really important to think, and I encourage everyone in my group at least around NERSC to think about what are those on-ramps? And so how do we enable the user who has something on their laptop to bring it to NERSC and to start scaling up and get benefit? So anyway, I think that's an important consideration for everyone. And I'll pass the torch to Nestor since you have your hand up.
So talking about what if it were really easy, I have given, what was the title? High performance computing in C++ classes to students. And turns out the high performance part is not the hard part. The hard part is they might not be comfortable with using the shell, with using SSH. Then there is the with using C++ part. And once you have got them comfortable with all of that, you explain OpenMP and they're like, oh, that's easy. The parallelism part turns out is often easy. It's all of those tiny bits of friction that are making it a lot harder for people to go from, I know how to do this thing on my laptop to, I'm going to run that thing on a supercomputer. And NERSC is doing a lot of great job with having a very, very solid documentation that's kept up to date and tries to listen to users' pain points. But often it's spending a full day on a workshop with users, getting them from you have never used a supercomputer to here is a solid setup that's letting you do the things you want to do. Just it's an education problem very often rather than the thing is difficult problem because we are lucky we live in an age where those things have never been easier than they currently are.
And well, Alan, did you have any other additional insight that you wanted to add, or?
Oh, I mean, probably, but I think I'll just keep it that I'm glad that people are concerned about the on-ramp and all those little bits of friction because I think that just having the words on-ramp and the words friction in a conversation is an incredible start, because I haven't really heard enough of that until today.
Awesome. Amanda, you wanted to add something else?
No, yeah, I like to say that Nestor said that it's easy. I agree that some languages are easier than others when we are talking about parallel programming language, like OpenMP is much easier to use than, for example, CUDA or SQL or OpenCL. Like SQL and CUDA. Like SQL and CUDA, I think we have to spend a little time to learn these languages. It's not so easy as OpenMP, for example. But I also think that if the users are running their jobs in their laptops, it means that what they are doing, the laptop is okay. They are able to do what they need in their laptops, because when you really need, for example, in my case, my first HPC project, before porting this code to a parallel code, it was a sequential code. It was like really slow. It was not possible to do my research if I continue on working in my laptop. So this is a decision that there is no option. I have to go to some machine faster. So I think when you are doing a research that you really need to go to a supercomputer, there's no way you have to go there, because otherwise you're gonna wait for hours to finish what you want. So it's impossible. So I think this movement from desktop, from laptops to supercomputer is according to your necessity. And of course, we have some easier language to start, but you need to spend some time to learn other language like CUDA and SQL, for example.
Yeah. Excellent points, Amanda. Nestor, you had some other points to add?
So, yes, to the fact that some things are still hard, very much so. GPU computing, like in JAX, it's really nice. In CUDA, it can be a massive pain and tricky to do. Yes, very much so. But one big caveat to the idea that at some point, if you need the computing, you're going to go and get the computing is, I have known people who waited 24 hours for their stuff to run on their laptop, and who told me we cannot scale up our data set because that will be too long. And they just ran something sequential on their laptop. They had no idea how to make it parallel. They were not quite sure what to do with a supercomputer if you gave one to them. So they were like, this is the limit of the problem size we can deal with at the moment. So we think of it because we know of those resources, but not everyone knows of those resources and of how to access them.
Okay, awesome. Awesome. Did any of our users have any insights that they wanted to contribute or add, or any questions? Well, Amanda, did you want to chime in with another
Yeah.
point?
I'd like just to say to users that the way that I started, I didn't start using a supercomputer. It's kind of, oh my God, I don't know how to do it, how to enter in a supercomputer, how to use it. So it's kind of a little scared. So how I started as a user, I started first using a sequential code. And then when it was not possible anymore, I started with, like, I have a desktop, a personal desktop. We have 4 GPUs and eight CPU cores only. So it's easier to start. It's kind of your own machine. It's not so big as a supercomputer, but it's enough for what I needed at that time. And then after learning how to do how to to do my code, to implement my code in parallel, using the GPUs in my desktop, the CPUs in my desktop. Then I go to the supercomputer. So it was kind of one step by step, like, so I think maybe it's a good way to breaking these barriers that we have.
Awesome, excellent point. Julian, you made a comment in the chat. Did you want to elaborate a little bit more, or?
Yeah, I mean, I think my comment really gets to the, the point I'm trying to make, which is when, and this is not necessarily specific to languages, although languages, and I have Julia in mind in particular, languages can do a lot to improve how difficult certain systems are to program for. But at the bottom, when you're actually talking about like what hardware am I going to use for whatever I'm doing, whatever the language is, the question is, how hard is it to actually use that resource? How hard is it to parallelize it? How hard is it to even like start up a session and use a GPU or do something simple? And I think languages have a we may never get out of the hell that is supercomputer, library maintenance and packaging and all that. But at the very least, I do think languages could go a long way towards smoothing over a lot of these difficulties. And I've found that using Julia, I mean, I've had very few issues compared to other languages when I have to do cross-language benchmarking or stuff like that.
Awesome. And Brandon, you wanted to add some additional insight?
Sure. Yeah. So yeah, thanks, Julian, for raising that point. I mean, I think the ecosystem that comes with software in general is hugely important, right? And that's kind of some languages have better package management stories than others. Let's say, Rust is, I think, a poster child for doing it well. Python, there's like 20 different ways to distribute something. And I guess I can maybe plug Johannes and a couple others here as well. And, I happen to know that we do actively talk to the kind of upstream projects whenever we can, and work with them to try to enhance their packaging systems. A lot of times they come in with these assumptions about, oh, it's a single user deployment that's local on your laptop, right? And sometimes that model doesn't necessarily translate to being able to deploy things on a specific HPC platform. And there's also a lot of kind of glue and infrastructure bits. So for example, like a recent development that you can look forward to in the future is there's now an ABI specification for MPI. And you might ask, well, why do I care? Well, having a good ABI lets us get away from, having to do a custom MPI for Pi build that's outside of, or like weird HPC thing in some way, as opposed to standard packaging mechanism for the rest of the world. And so that's a thing that we've tracked and supported, and are kind of really looking at leveraging. So I guess I would turn it around and say, like, great point. And please flag to us when you run into any kind of those types of issues. I won't sit here and promise to like fix C++ software packaging systems, but at least identifying those issues gives us a chance to kind of chip away at them. And then I guess for users in general, it's also important to remind our funding sources that when I was doing computational science, nobody asked me about like, hey, did you make your build system for your library sane, right? And so kind of reminding our sponsors that it's okay to spend a little bit extra time on quality if we want to kind of realize that long-term impact from certain research products. That's my soapbox for that one.
No, awesome. Excellent points. Excellent points. Let's go to the chat. We had a question from Robert. Robert, did you want to pose your question to the panelists or to the group?
Sure. Hi, Charles. So as someone who is a Fortran programmer and has been doing Fortran programmer and doing high performance computing for many, many years, I have a Fortran with MPI code that runs on thousands of cores, and I'd like to make the transition to GPUs. I'd like it to be something that can be moved from one platform to another. And so my question is, what advice would you give to someone in my position?
Mm. Who would like to take the floor? Maybe I think Amanda, if you've worked with so many different
Yeah,
libraries, did you have any thoughts?
but I
And then
think I'm
Brandon
not.
next.
Yeah, I can say that I'm not the right person because I don't work with Fortran. So yeah, I know there are some other panelists that work with Fortran. Maybe they know better than me.
Or you could consider if it was any language plus MPI, what advice would you give? Maybe. Does that help maybe give you a different frame of it? If you want to think about it, let's let Brandon go ahead and jump in and maybe you think about that and see if you have any thought.
Yeah, so tell me if people are sick from hearing from me, but I think looking at the panel, I might be the de facto Fortran person here.
Go for it. Go for it.
So yeah, great question, Robert. I think there's a couple other factors to kind of consider of, what does your code base look like, right? In terms of, how big is it? Are you on, I think a good initial step is to get your compiler that you're using and then turn on all of the sort of strict pedantic language checking flags. Quite often, I'll just say Fortran, certain compilers are guilty of not complaining at what I would describe as like Fortran-ish code. And so I think the first step towards kind of moving towards portability is to make sure you don't have any kind of hidden assumptions in there in terms of, the semantics of the language. Then the next steps also kind of depend on what your objectives are and who else is the developer besides you, and kind of what your target platforms look like. And I think there's also kind of an element of, do you have 2 or 3 really hotspot parts of your code that really drive the performance? Or do you have like some big climate model where there's 10,000, different kernels that matter?
Yeah. It's more like one kernel that matters, and the code is pretty strict. It's very strict Fortran. It compiles with all the Fortran compilers at NERSC. I can tell you, I've previously, in years gone by, it's been suggested to me, rewrite the code in OpenMPI and then use GPU offload. And sort of my question is sort of like, so is that what I really should do, or are there or should I learn a completely new language? Or if I want to stick with something like Fortran, then is GPU offload the natural thing for me to try? Can you comment on that?
Sure. Yeah. So I think in the most a recent development that's I think pretty exciting is Fortran has parallel features built into it that are really starting to be a thing that you could realistically leverage in applications. Fortran does have a little bit of a weakness in terms of memory model compared to, or lack of a memory model compared to some other languages. So my 2 cents, without having seen your code at all, right, is if you have more straightforward, I would say loopy code that's sort of, nested do loops on kind of dense data structures without a lot of complex hierarchical components, then something like do concurrent is really great and straightforward to leverage, and that can be automatically offloaded. Also, several of the native language features or intrinsics, like for example, matmul can be offloaded by modern compilers. So that's a good place to start. Then, I think a reasonable next step would be to think about adding a little bit of OpenMP if you don't want to embark on a major rewrite of your application. So, I think every situation is always unique of like exactly what the recommendation is. So I would suggest those two things, and then also to kind of think about adopting a kind of unified memory approach instead of worrying about the manual data movement. A lot of modern architectures sort of will manage the data movement aspects for you for free, and the Fortran language doesn't really have a lot of constructs for that for you. And so that would be kind of my first pass recommendation. And then, yeah, I see Trey's point in the chat that, OpenMP is a great tool, but it can also, you can end up writing more directives than the code that the directives go with, especially with GPU offload. And there's some gotchas with that approach as well. And so anyway, yeah, I see Rahul's got a hand up, so maybe I'll pass that over to him.
Go for it, Rahul.
It's most of the things that I actually wanted to say have already been said by Brandon or by Trey in the chat. No. I actually had my hand up to answer Ankur, who was asking a question, but that's probably for the next. I don't want to disturb this flow of the conversation that's happening here.
Well, no. If you want to, Encore, did you want to elaborate a little bit more on your question, and then maybe Rahul can provide his thoughts, or?
Yeah. Question is on being a user of NERSC as a graduate student in atmospheric science, so a different field from a lot of like high performance computing. I think the way that I've gotten things going has just been through Google searches and really helpful NERSC help desk engagements when I'm stuck, especially with like package loading or getting the MPI to properly recognize the world size, things like that. And a lot of times, I think the only person who's written or looked at the code that I write is me. Sometimes is the nature of grad school. And so as I work on it, I'm wondering if I'm doing this the right way. One solution out of that, at least in our field, has been the use of DASC, which is integrated with like Python distributed world, trying to sort of automate away a lot of the decisions that you have to make in parallelizing code. But I found that for a lot of the use cases that I have, DASC doesn't work as seamlessly as I'd hope. So then I transitioned to a different tool, and then I'm kind of back where I started, where I don't know if I'm doing this the right way. And I'm wondering if there are ways we can leverage some sort of simplified pair programming in the context of everyone's scheduling constraints so you can kind of learn from others as you do, like learn by doing. But I found pair programming to be a really helpful way.
Yeah, awesome.
Right.
Rahul,
Thanks for that question. Yeah. Actually, that's a really good question. And when I was reading the chat message, I actually thought you're asking about GPU programming models because that's what the topic was going around. But you mentioned that it's about MPI, but that's fine too. So just to
But also for the
GPUs too. So there is, I think I see Brand has already posted it. There are a lot of trainings that happen at NERSC. For these, there's actually a new a training coming up. I think it's called the NERSC NWAYS Bootcamp, which kind of which is organized in a way that it will show you how to write OpenECC code, CUDA code, OpenMP code for GPUs. What are the advantages and disadvantages of each, and then you can choose what fits best for you. With respect to MPI, I don't know of an MPI course, of an MPI training at NERSC, but about the pair programming, there a while ago we were hosting this open office kind of sessions where for folks who are uh, slowly moving from like our CPU based machine to a GPU based machine, where we teach them more about like how to do parallel programming, GPUs, even MPI codes. We help them out. Uh, I think there is a plan to do that again soon. So you could register for that too, where some expert could come and take a look, and then you would not be the only pair of eyes looking at your code, but somebody else can help you, do that or register for hackathons like Brandon has suggested in the chat. And that's a really good place to have some experts look at the code and not just about the code that you have written, but about how to actually think about the parallelization strategies and like what are the gotchas that you might run into at some point in the future.
And I wanted to also add in an additional comment that, every summer we offer a supercomputing crash course led by our group lead, Rebecca Hartman Baker. And so if you are not familiar with MPI or an OpenMP, that would be a good training for you to attend. And so be on the lookout for announcements about those upcoming trainings in our weekly email. This has been an absolutely fabulous conversation. We're at the top of the hour. And so what I did want to do is give the floor back to our panelists to offer any closing thoughts that you may have. And Amanda, you have your hand up first. So we will let you go ahead and go first.
Okay, no, I just would like to add that if you don't want to wait these trainings to join at the time they are giving these trainings, we have these trainings are recorded. So we have them in the YouTube channel. So yeah, if you need them now, if you need to know this information now, you can go to the YouTube channel and watch this training there. Yeah.
Yeah, awesome. And we have, as Amanda mentioned, all of those trainings from the past are recorded and the materials and everything is available to you. So you can go ahead and review those, or you can attend a live session when we have it next too. Good point, Amanda. And
Yeah.
Brandon, did you have thoughts?
Yeah, I just wanted to close out one thing. So yeah, lots of great discussion on training and hackathons and so on. But I did want to just explicitly call out one more point, which is, we don't have an HPC help desk. We have a team of really great HPC consultants, and they are also there to kind of support users getting the most out of the system, beyond just like, oh, I found this bug or the thing doesn't work. It's, as someone who used to do that years ago, I thought it was always great when I got a ticket that was like, hey, I've got this cool science application or library, and I'm trying to make the most of it on a NERSC system. And that can actually be a great way to open the door on some interesting collaborations. So don't be afraid to, tickets aren't just for bugs, right? It's also for an opportunity to collaborate with experts here at NERSC.
Yeah, and that's an excellent point, Brandon. We're a DOE user facility, so it's our job to help you achieve your science in the best way possible. So, make use of us. That's our job. Johannes, you wanted to add something in?
Since you're talking about closing remarks, something that here's something that keeps me up at night, not literally, but like figuratively in terms of research projects. And it is, I've been in this position before. By the way, I think most people at NERSC are recovering academics. Like we were NERSC users at some point, and we realized the people we're talking to on the ticket seem very happy, and they seem to also do interesting research. And then we start applying for jobs here, and that's how we get here. So while I was still an academic, frequently the research problems that I chose and also the solutions that I built were often built on assumptions that I had about the system that I was on, right? Like it could be something as simple as, oh, I can't do a big run because my computer would never finish over the weekend. That's sort of the very simple one. And so I encourage everyone to really think about what assumptions that you've made about what's possible that might have been, or more precisely, what assumptions you're making about what's impossible. They might have been good assumptions 5 years ago. There might be good assumptions based on the hardware you have right now, or that the people that you've talked to. Please try to evaluate those regularly, right? Sometimes new technologies, new things come along that actually break those assumptions and that enable you to do really cool new research. And the thing that keeps me up at night is like, how much are we limiting ourselves based on those assumptions? So that's sort of my parting thought, really. Reevaluate everything you do like every year.
Yeah, good points and good advice. Nestor, did you want to contribute your thoughts?
Yes. Following on what Johannes said, I saw a fantastic talk by a Finnish researcher, and one thing she said, she went even further than Johannes. Instead of questioning her assumption, she assumed that in the future, computers will be fast enough to treat some problem size that were impossible to imagine in the present. And so she started thinking, okay, what building blocks can I get ready right now so that when we have the computing power, then I can be able to do that science as soon as the computing power gets to us. And I thought that was a really interesting way to think about things. And also for people who are hearing about other programming language and are like, okay, that's nice, but I don't know Julia, I don't know Rust, I don't know those things. So they might seem interesting, but I cannot use them at the moment. There is a really great way to get practiced with a programming language. That's doing the advent of code. That's a thing during December where every day you have a problem in two parts, a very easy one and a harder one. You don't have to do everything, but pick a programming language you don't know or you want to learn and do the advent of code. You don't have to do every day, but just even half of it. That's going to give you a very wide foundation programming language. And that's a great way to get the ball rolling on, oh, maybe I don't want to ever touch that language again. Or maybe that was great and I could see myself using it for my research.
And Rahul, did you have any closing remarks and thoughts?
All my closing remarks and thoughts are stolen by the rest four panelists. But I just want to reiterate that we have an excellent training season ahead, and we have had them in the past. All the trainings are recorded, like Amanda mentioned. Please go through them. I think there is also at some point there's also a panel similarly like this, which discuss about which programming model might suit best for you. So look at that. Or like Brandon said, raise a ticket, and it just does not need to be about like, hey, this is not working or that is not working. It can be about a more researchy idea, like I'm trying to do this. I have had research collaborations like this, starting from tickets uh, when I'm in the duty there. That even led to successful like paper submissions and things like that. Apart from that, I just want to mention that there is also an effort that was actually spearheaded by Johannes. I'm surprised you didn't mention that, Johannes, about where you can book time with our experts, like an hour time or a half an hour time, where we actually come, like we all, like, the person the user who's booking the time with a particular specialist, you get like a complete focused 1 hour or 30 minutes of the expert's time to look at your code or any other question that you might have in general. People have signed me up for, like, looking at their code, and we have had discussions past that or pre that, just to get ready for that 1 hour of, like, focused hackathon kind of thing. I've also had discussions about when people have said, okay, I'm trying to use OpenMP or Cocos, and that gets directed to me. So I'm like, what are the things that I should be aware of when I do this and things like that. So please make use of that facility too.
Yeah, and great points from Raul. We're here to help you again, and we offer help in different avenues. It could be through, a ticket, through booking a one-on-one appointment, many ways for you to get assistance from us. Amanda, did you want to add any additional thoughts? I saw your hand up.
Yeah, I would like just to say that sometimes we think that we are saving time doing the simplest thing, choosing the simplest way, but sometimes it's better to spend some time learning a new language, for example, and doing things slowly, but then in the future we are saving a lot of time doing the right choices when you are starting. So yeah.
Okay, awesome. And Johannes provided a link to our docs that allows for you to schedule a one-on-one live appointment with us. So please refer to that link if you do need additional help. We're a little bit over the hour, and so I want to thank all of our panelists for their contributing their wonderful thoughts and participating. And also to all of our users here, that the discussion has been absolutely wonderful and very much informative and appreciated. Please join us again tomorrow at the same time for our panel with our NERSC Early Career Award winners. It'll be a very similar discussion focusing on understanding programming languages and the scientific research that our Early Career Award winners have been able to use. So we hope that you can join us again tomorrow. But again, thank you all for a wonderful discussion and interactive and engaging panel. And I hope you have a wonderful rest of your day, and hopefully I'll see you again tomorrow. Thank you, everybody.
Have a good day, everyone. Bye-bye.
Bye-bye. Thanks.